Today we're going to talk about rearranging formulas. So in yesterday's lesson, we looked at how to rearrange basic formulas that just had one operation, like addition or subtraction or a power that had to be moved to the other side. Today we're going to be looking at formulas that involve two or more operations that need to be rearranged. So we're going to do the same thing that we did in our lesson yesterday. We're going to solve an equation, and then we're going to try rearranging a very similar formula. So we're going to start here. It says solve, and I have 2x take away 7 equals 13. We have solved a lot of equations so far this year, so we should all hopefully know how to do this. So I'm going to start by taking that subtract 7, and I'm going to add 7 to both sides. So I get 2x equals 13 plus 7 is 20. And then I'm going to try to cancel out that multiply by 2 by dividing both sides by 2 to get that x equals 10. So just a reminder, when we are solving an equation, we are using order of operations in reverse. So if order of operations is BEDMAS, then BEDMAS backwards is SAMDEB. So you'll notice that we started by moving the subtraction before we moved the multiplication, right? So addition and subtraction gets moved first, then multiplication and division, then exponents, and then potentially brackets, although we learned that you just multiply those brackets out so that they're not there anymore. Okay, so we're going to try same idea. It's just instead of numbers, we have letters. So it says rearrange to isolate x. Isolate means get it by itself. So we want to find a way to get that x all by itself. It's feeling antisocial today, and it just wants everybody else to go away. So we've got a, we are multiplying by a, and we have minus b, we are subtracting b. So I always want to focus on what the operation is in relation to x. So a is being multiplied, b is being subtracted. So when I rearrange, I always start with addition and subtraction. So just like here, we started by adding 7. Here I'm going to start by adding b. So I'm going to get ax equals c plus b. The only difference between these is that I can't actually add the numbers together because I don't know what c and b are, and they are not like terms. From here, I need to cancel out that multiplication with a, and I'm going to do that by dividing by a. So I'm going to write that x equals c plus b, and I like to do my division as a fraction, so all divided by a. If you wanted to write it using the division sign like this, you would have to put c and b in a bracket to show that they're together and that they're being divided by a. So I much prefer just to write it as a fraction. All right, we're going to try another one. So I have 3x squared plus 1 equals 49. So when I'm solving this equation, I'm looking first at addition and subtraction. I have a plus 1, so I'm going to do the opposite and subtract 1. So I get 3x squared equals 49 take away 1 is 48. Okay, from here, I now have a multiplication by 3 and a power. So we do our multiplication and division next. So to cancel out that multiply by 3, I am going to divide both sides by 3. So I get x squared equals 48 divided by 3 is 16. You can use a calculator if you need to. And then from here, to cancel out that square, I'm going to do the opposite and do the square root. So I get x equals the square root of 16, which is 4. You can also use your calculator for that if you need to. So our formula on the other side is the same idea. It's got multiplication, it's got a power, and it's got addition. So we are going to try to follow the same steps. I did start by just highlighting what we're isolating, which is x. So when you're rearranging, we are always doing order of operations in reverse. So I'm going to start with any addition or subtraction. That's going to be the first thing that I try to rearrange. So that's going to be that plus b. I'm going to cancel it out by doing a minus b. So I have ax squared equals c take away b. They're not like terms, so I can't actually subtract them. Then I would look for M's and D's, multiplications and divisions. So I've got multiplication by A. We are multiplying our X by A. So I would start by dividing by A. Now I like to write mine as a fraction. So I'm going to say this is C take away B divided by A. I don't think I gave myself enough space here. And then my last step is I need to cancel out this square, and we are going to do that by doing a square root. So that means that X is going to equal C take away B divided by A, and then that whole thing in a square root. So your square root does need to go all the way down to the bottom of the A and all the way over the top of the numerator. So it needs to make sure that it's covering that whole thing. So we subtracted B, then we divided by A, and then we square rooted. Okay, we have one more set. I have 5x divided by 3 equals 10. So we're going to solve. I've got multiplication by 5 and division by 3. I think I'm going to try to get rid of the division first. So to cancel out that divide by 3, I'm going to multiply by 3. So I get 5x equals 10 times 3 is 30. And then I'm going to divide both of them by 5. So 30 divided by 5 is 6. So x is going to equal 6. So when I go to rearrange to isolate for x in the next one, I'm going to follow the same steps I just did, except we're just not using numbers. So I have a times x, I have b is being divided by x, x is being divided by b, and then that equals c. So I have a choice. You can get rid of the multiplication or the division first. I like to do the division. It's a little easier. So I'm going to cancel out the divide by b by multiplying by b. So I have ax equals, and then I'm going to write c times b. I'm going to use a bracket. You could use the dot. I would not advise using the x because we have an x in our formula. And then I'm going to divide by a. So x equals c times b, and then all divided by a. And there's my rearranged formula. So we're going to look at two last ones. They're a little trickier. And we want to just rearrange in both of these to isolate for a. So I am trying to get the a all by itself. So just some basics. It is easier if the A or whatever letter you're rearranging for is on the left-hand side, which I already have, so that's good. When we do this one, we'll flip it over just to make it a little easier for you. So I have a squared plus b squared equals c squared. It's the Pythagorean theorem. So I want to rearrange to get a all by itself. Now, when I'm looking at rearranging, I notice the b has a squared, the c has a squared. When do I square root? When do I not square root? What you want to do is focus on the operations in relation to a. So a has a square on it, and a also has a b squared being added onto it, right? So we're looking at the a. What's happening to a? A is being squared. A has a b squared being added onto it. I don't care that the b is squared. We're not trying to rearrange for b. We're just interested in a. What's happening to a? So if I have a square, which is an exponent, and I have addition, which is what this is, I move the addition and subtraction before I do the exponents. So I would start by subtracting b squared from both sides. So I have a squared equals c squared and b squared are not like terms. They don't have the same variable. So I'm just going to write it as c squared minus b squared. And then to cancel out a square, we square root. So I'm going to get that a equals the square root of c squared minus b squared. And that square root needs to go over the whole thing to show that the whole thing is being square rooted. Okay, we have one more to do. I have EF equals A divided by B plus C, take away D. So the letter we're trying to isolate for is A. I don't like that it's on the right-hand side, so I'm going to flip this equation over. You don't have to, but I am going to. So I'm leaving both sides exactly the same. I'm just trading what side they're on. So we are still trying to isolate for A. So I want to think about what's happening to A. A is being divided by B. We are adding a C, and we are subtracting a D. So I know that the C and the D are side by side, but really we are adding C, we are subtracting D. So when I go to rearrange this, I'm going to try to look at doing this in reverse order of operations. So that means addition and subtraction are going to go first. And they have the same priority, so it doesn't matter which one you do first. So I think I might get rid of the D just because it's on the end. So I would maybe start by adding D to both sides. So I'm going to get A divided by B plus C equals EF plus D. They're not like terms, so I can't really do anything with them except write that they're being added. And then I can cancel out that that plus C by doing minus C on both sides. So A over B equals EF plus D, take away C. All right, and our last step, we want to try to cancel out that divide by B. So I'm going to multiply both sides by B. Now, when I'm multiplying both sides by B, there are two ways I can do this. Number one, I could just say that we are multiplying this whole side by B. So I'm going to put EF, I'm going to do B times EF plus D minus C, and I'm going to put it in a bracket to show that the whole thing, EF plus D minus C, is being multiplied by B. Your other option is that you could multiply the B into the whole thing. So you could multiply everything by B. So you could do B times EF, which would be BEF. You could do B times D, which would be BD. And you could do C times D, which would be CD. So I would accept either one of these, either with the bracket, that's perfectly fine, or you could actually multiply every single one of them. You know what? That's a CB, not a CD. Sorry about that. My mistake. So I have BEF plus BD plus, minus, I probably should have written BC, but it's too late for that. You just want to make sure you multiply them all by B, or just write it with the bracket, which is probably what I would do if I was doing this question. Okay, so try your practice questions, and that's it for your lesson today.